points from Flight 3 was the roll control didn't work quite as well as we wanted it to. We learned that we needed some redundancies, so we added more roll control thrusters, and we'll see those in action as well today, as that was a Flight 3 learning that worked better on Flight 4 and still enabling that same design today.
Beautiful.
Yeah.
Starship has passed through 85 kilometers altitude. Flaps now have control of the vehicle.
Imagine this is live
Great
camera.
call out.
Instant
Kate
starting.
mentioned the flaps are controlling the attitude of the vehicle. And I love these
camera.
views because it looks so calm. Everything is relative, right? So
Okay,
relative
doesn't-
to this camera on the ship, it looks so calm and
Where
smooth. The
the
vehicle is traveling
flap out?
extremely fast. You can see the speed on the bottom right-hand
Flow is very
corner of
laminar.
your screen. Starship is designed to land on Mars
that's
where there are
beautiful.
no runways or other humans to help out. So we also want rapid reusability. So we're doing propulsive landing instead of a more traditional means like parachutes. And so we will use the engines
That's a lot
on
of heat.
this vehicle to help slow the vehicle down for a vertical landing.
Yeah. Now, entry is going to basically happen in 5 phases. The first is low drag that lasts for about 3 minutes. Next is high heating, and that beginning when heating
Speed
increases
starts going down more rapidly.
above the heat rate breakup limit. That lasts for about 10 minutes. We then have high dynamic pressure. Starship will continue to slow down and experience increased aerodynamic loads during that phase, and that will happen before reaching Mach 1, about a minute after.
Starship is approaching the peak heating phase of entry,
Okay,
remains on a
peak
nominal
heating.
trajectory.
Okay, so that was phase
Look at
2 that he just called out, that I was mentioning.
Oh,
After
don't touch-
peak
oh,
heating
no,
is
no,
that
no,
dynamic
don't touch
pressure
the flap.
around Mach 1.
Look at the flaps.
And that will
Yeah, the flaps.
last about a minute after leaving the hypersonic
four.
area, and then we go
Almost
into
destroyed the
subsonic,
the
and then
flap,
of
but we
course
still landed in
landing
the
burn.
ocean.
Wow, what an incredible
Please,
view.
Don't.
Remember? Remember,
Why
as I
does
said
move it?
earlier, as soon as you see sparks flying or even entire tiles, something is off. So you already saw that on the aft flap there.
Live visual.
Speaking of live
Move it
visual,
further or
the
something.
flap, we have
Oh, nice.
more views,
This is a good-
more cameras on board Starship, as Dan mentioned a few minutes ago.
Can you move
We
me
are
more into the
hoping
corner?
that all 4 flaps will stay more intact than they did last time. We did make
Really?
some changes
I
to the
hope so.
design in order to help enable
Starship
this.
is now experiencing peak heating, remains on a nominal
further up.
entry trajectory.
Yep, there you go.
Can
Great
you
news
just
there
turn it
that Starship is
prevent
continuing
teenagers
along the
out
path
heating
that
from the
we
plasma?
intended it to fly. You can keep track with how fast it's going and
another
how high it
piece
is above
flying off.
Earth
Let me
using
check the
the
flap.
display
What I'm
that is there
concerned
on the bottom right-hand side of your screen.
This flap. You
Rapidly
see this?
reducing speed at this point.
This is where we're really
Last
going to
time we
see
almost
a lot
lost
of
the
those
ball.
improvements from Flight 4 really come into action. Is you guys kind of talked about, so
What
it's
seems to
called
be
the
holding up?
static arrow. Those are kind of the poke out points on the flaps. Those get exposed to some pretty extreme heat environments, and so
Oh,
we
the
added
heat.
some additional, basically made it a lot more robust for the thermal protection there. And we learned not just from visuals and stuff like that. We had those missing tile tests on Flight 4 where we intentionally left some out, kept in some backup
Same on this
layers.
one.
They're called ablatives, which
These
means
are
they just
upper speed,
gradually melt away to
You
help
already got the
dissipate the
booster or
heat.
the lower speed.
And we've got an entire layer of ablative underneath the tiles on this Starship
Yep.
today. So even if you get a gap in a tile or a tile is broken, anything like that, we've got essentially backup options. And what we're really trying to do today is do an on-target landing. As we lost
What if it
the
works?
flaps, you lose a lot of your control, and so we didn't land right on target
Oh, no.
last flight. This time
want to see
we're
that.
trying to really
That's
nail the
bad.
target within just tens of meters. And that'll just be a really huge step on feeling like we're closer to bringing a ship back. Obviously, there's a lot of work before we get there, but
What if it
we just
works?
caught a booster.
Physics is
We're
very
going to start
optimistic.
looking real soon at when we can catch a ship.
You see the colors forming on the map.
So the view on your left is as a helicopter passes by Dan, bound at Starbase. The view on your left is a camera that's positioned near the nose of the ship, looking basically down toward the flap. The view on the right is looking perpendicular to the flap. So we're looking basically bird's eye view onto the flap on the left-hand side, and then a worm's eye view
can see the
from
metal
the side
change color
with that
because
view
of
on the right.
The heat.
Yeah, sorry about that, guys. Maverick just buzzed the tower. He might be coming back, so.
Now, these views brought to us by Starlink, it's incredible that we have this high-definition capability.
Look at it,
In fact,
still good.
that view on the left...
Starship is now halfway through the peak heating phase of entry, remains on a good trajectory.
Okay, that's good.
What if it works?
So great news there, hearing that we're about
nice
halfway
one.
through the peak heating phase. Like I said earlier, this lasts roughly 10-ish minutes. And we did hear earlier that the flaps
even
have
this
control of the vehicle, so
works way
also
better than last
good
time.
news there. You know, it is incredible that we've
I think
basically
it will
had
work.
views the entire time.
Right. Yeah.
Although-
Thanks to Starlink.
My
Yes,
memory
hold up,
did
please.
black out a little bit after
Please
booster
do.
catch, so I think we had views. But, you know, all through the coast phase, we had some beautiful views of planet Earth behind the ship as it was in its orbit.
Yeah, and I also do want to point out on your right-hand screen, we've got
Nice.
a more encompassed view of the flap. As we watched in Flight 4, the hinge area was the area where we got a little bit of that burn through. This view, this new camera view on the ship will help us be able to visually see more of what's happening in that area. And again, we have improved our heating tiles, and so hopefully we've protected the hinge a lot better this time.
Landing chill has started.
But again, these views are additional to the data that we get on these flight tests that
Beautiful.
help enable us kind of put the data that we get in the computer to the visuals that we see and try and align those and use that for improvements in the future.
Now, we heard a call out there saying that engine chill has begun. This is an indication that we are starting to flow a little bit of the super cold liquid oxygen
performing
through
excellent.
the hardware, through the Raptor engine, specifically the turbo pumps, to help ensure that the hardware is at the right temperature before we give a full push, a full flow of propellant at engine startup.
Okay.
So all of that to say, we are getting closer to the landing bird.
We definitely are, and again, if you look at the bottom right hand of your
Look at that
screen, you can
plasma.
see
It's
the
out of
altitude that the
speed.
ship is, and it has been
this flap
slowly
survives.
making
Look
its way closer and closer to Earth. We're currently
hope
at
it
about
survives.
63 kilometers from planet Earth, and you'll see that number trend lower and lower
those
as we get
colors.
closer and continue through this
That's
reentry.
nice camera.
Yeah,
Right
this
there.
is going to go on for a little, actually, a while longer. We have about
Nobody's
10 minutes
even
or
talking
so,
about this
roughly, before
Getting
we
tested,
execute the
screening this.
landing, the ignition for
Like
the
that?
landing burn, starting with the landing flip. So we're making a controlled reentry. This is one of the primary objectives for Starship today, is to demonstrate another controlled reentry, even more
Oh,
controlled
let the
than
flap
what
not
we saw
burn,
on
please.
Flight
Look
4.
at that,
And
like
so
it's
far,
on
that
fire.
is looking
Looks
good.
excellent. Yes.
It's holding up.
I mean, it's not perfect because you can see the sparks and everything, and that
as
means
I think
we-
it's
it's
doing
not.
better than last time.
As we start to really get lower, we're going to start seeing the atmosphere's
that.
effects
Don't
start to
burn,
take
please.
place, and that's when
Don't
we'll start.
burn.
We'll be dropping our speed down closer to the speed of sound. You'll see the flaps start to maneuver. We were able to do a landing burn on Flight 4, which kind of caught all of us off guard. It was pretty incredible after seeing the flaps survive through. And we're going to try and do another one on this flight today. We tweaked it a little bit, so we're going to try and splash down at a little bit of a gentler angle this time instead of just kind of hit the water and fall over. And the goal with that is try and keep the ship intact, and then if
feel
we're
like I
able
can-
to then get some additional video of it,
I can
again,
just
that's
push
just
time
more
forward.
data. And
Let it go faster.
everything we can see, everything we can get extra, like a couple extra seconds or minutes of data coming from the ship after
Starship has
splashdown.
passed through the peak heating
Get
phase
in.
of flight, approaching maximum entry dynamic pressure.
Thank you.
Yes.
Please, let's pass
All right,
this,
we're
this thing.
Come on.
through peak
This is the
heating.
danger.
Coming up
Full
is
danger spot.
basically Max Q
Look at
Part
that.
2, where
Please hold up, flap.
we're going to hit kind of that part of the curve where we're still moving really fast, and the atmosphere is just dense enough that we're feeling the most pressure. But hopefully, we're going to start feeling a little bit less heat now.
All right, 1 second there. Somebody just said that the sparks that we're seeing is the ablative material, but the ablative material is below the heat tiles, so it's not supposed to ablate. It's just a last line of defense.
Down to Earth.
Really? I don't think so. I hope
And
not.
But
we
this
did pass
looks
through
way better
peak
than on
heating
Flight
and
4.
still
Yes,
got
exactly
really
what I
good
said. It looks
views
way
throughout
better.
that whole
So
period.
not
Typically, during the highest
So it will be better. It
heat
will make
on
it.
the vehicle,
This is
we
holding up.
tend to build
Last
up a
time,
lot
the
of
other one was
plasma, and that's
almost
typically
tearing
when we
down
would lose,
Way
connection
Yeah.
or views
Holding
of the
up.
vehicle. But again, with Starlink, we were able to get some live views throughout that entire process
The
there.
fact that we are almost past this stage.
And
are
we're
doing
coming
good.
up. We'll start hearing a couple more milestones in about 4 minutes or so when we start getting down to like the transonic, the subsonic, when we're starting to move closer to and
Yeah,
beneath the speed of sound.
1,400.
And I mean,
Wait,
we're getting live
14,700
views, we're getting
kilometers
live
per hour.
data. We've got a couple
That's a
additional tests
Altitude
on
for
this
54
one today, where we left off some missing tiles again to test some additional backup layers. We also
look at the
have, I
tiles
don't know if
glowing
we
red.
can still quite
get
see them
over
in this
this
view,
page,
but you
please.
may have noticed we had
Look
some
at this.
kind of silvery looking tiles
Look at this.
on Starship as well.
Starting to form a
And
red
those were
color on the base of the
pretty much
flap.
standard tiles, but they were wrapped in
Let's get it
aluminum.
over with,
And it
please.
was a pretty simplistic, straightforward one where
Oh, there it
aluminum
goes.
starts to melt at roughly the
Yep.
same temperature where steel starts to lose its strength, not necessarily melt. And so
there it goes. Yeah.
if we see stuff
That's what I
melting,
meant.
we know
still
what our
better
steel's
than
going to be
before, though.
exposed to. But
Faster, please.
12,000
59
kilometers
minutes
per hour.
since launch, should be coming up on transonic and everything in just about 3 minutes.
It's decelerating real
Now the
quick.
views here, we have coverage of all 4 flaps. We can see, so for those that perhaps didn't catch a glimpse of the vehicle before liftoff, there are 2 flaps at the forward end and 2 flaps at the aft end. The larger camera view that is there on the
Aft
right-hand
flaps
side of your
look way
screen,
better.
that is a view of one of the aft end or the
These numbers
bottom
to move
end
faster. See the
flaps.
numbers on the screen right there?
We can start to see some heat
speed is
buildup
at
and peeking through
10,500.
on one of the flaps there in the top
Altitude
left-hand
46
corner of your
kilometers.
screen.
Yeah, that is not nominal. What you see in the upper left is the same burn through that we
Once
saw in the
again,
last launch,
Starship
but
now at T plus 1 hour and 9
and there it
seconds
starts on the other
into
flap.
its flight today, re-entering the Earth's atmosphere. Currently about 45 kilometers above the surface of the Earth, now 44. We are targeting a soft splashdown in the Indian Ocean, about, northwest-ish of Australia. And we are attempting to, as we did on Flight 4, perform a flip maneuver as well as a...
Starship is at maximum entry dynamic pressure, remains on a good trajectory.
yeah.
But
All right, so that is great news there. Like Dan said earlier, this is basically max
What I can
Q
see here,
part
what I
2.
can see here clearly, I'm going to really quick mute Kate here. Forgive me. So what I can see here is that the heat shield of a Starship is not supposed to be ablative. What they were talking about earlier is an ablative layer below the heat tiles as a last line of defense. What you can see here right now is massive ablation, meaning the tiles on top, even the improved ones, likely still need more improvement.
Sure.
But that was to be expected, and so far it is still working, and there's a good chance we might see a soft splashdown, but this would not be reusable.
Good. That numbers are good. The numbers are amazing.
Now the 4
We are
flaps
5,000
on the
kilometers per
ship
hour. That's good.
help steer the vehicle,
That's
and
good.
one of the
Let's
main
go.
objectives for the ship
Let's
today
get to that,
is
please.
to demonstrate controlled re-entry
Let's
during
accelerate,
this
please.
phase of flight,
Come
this
on.
re-entry phase.
We lost the feed.
Come on.
And we have 6 engines on ship, but we only need 3 of them, the 3 sea-level engines. We will have that flip maneuver happen very close to touching down for splashdown. We'll do that flip maneuver, ignite those engines, slow the vehicle down
3 minutes from
immediately, and then hopefully have what we call a soft splash.
Nice.
It's traveling
Five
through
to
the speed
go.
of sound.
Coming up
That's
soon.
good news.
Landing prep.
Hey, riding ban. Riding ban.
Come on. Water. That's it.
Splashing down into the ocean.
And in front of
Touchdown!
Nice.
Ah!
They're letting it run.
Touchdown! Successful!
Nice.
Must here you come.
into Starship's journey, a live view from a buoy that